Hello all. Today we are going to see about the topics under liquid and solid based additive manufacturing. In this, today we are going to see about stereolithography apparatus. It is simply abbreviated as SLA. SLA belongs to the liquid based additive manufacturing technique. In SLA technology, there is a laser. That laser scans the photosensitive resin. So this resin, that is the liquid resin, is converted into a solid particle by the application of the laser. So this is the working principle of the or schematic diagram of the selective applications of the stereolithography apparatus. So this stereolithography apparatus consists of major components such as the computer control system. This computer control system is used to focus and amplify the light source, that is a laser source. And the next thing is the optical transmission. This optical transmission transmits or mirror that's positions the laser or scans the laser or points the laser upon the resin according to the given 3D model. The next component in the schematic diagram is the vat. Vat is nothing but a container which carries the liquid resin. The next object or next component is the build area. So this build area, you can see it is fully immersed in the resin. So this build area will be able to move in the upward and the downward direction. So this build area, once the resin is scanned by the laser, this build area goes downward direction so that the liquid resin comes and fills the topmost layer of the particle. So once it is filled on the top layer, again the laser scans the resin. So this scanned area again converted into a solid layer. Then the table moves downward. This action is repeated and hence we achieve the desired product through this technique. So you can see the table movement and the in the 3 dimension, that is the X, Y and Z dimension. So this laser you can see on the left hand image, that is image number 1, you can see the laser is able to move or focus in the XY direction. Whereas the build platform or the build area moves up and down direction, that is the Z direction. So the image 1 in the slide describes the initial stage of the component that is built by using this technique. And the image 2 shows the component that is partially built, and you can see how it is built and what is the position of the build platform. So here the resin used in this process is a photosensitive resin. So this resin, while it is scanned by laser application, then it is converted into liquid into a solid form from the liquid form. So this is about the description of the working. You can see here. So it is one of the process of rapid prototyping in which the layer by layer part is built with the application of laser. So the laser is used for the solidification of liquid resin. So according to the action of the laser beam, liquid resin gets solidified on the platform. So these are the major components: laser source, container and platform. So you can see the animated image, how the laser is scanned and how the build area is converted into a solid thing. You can see the laser that is first image, and the second is the direct light processing technique, and third is the liquid crystal display. So that is the three kind of sources that are used. So here the laser source is used to supply laser to solidify the liquid, and the container is a vessel which consists of the liquid resin. So let us see a 1 minute video of the working principle of the process.
Is SLA. SLA stands for Stereolithography, a 3D printing process that uses a UV laser to cure liquid resin into hardened plastic. Upside down or inverted stereolithography is the most common SLA system. Depending on the machine, resin is either poured into a tank by a user or dispensed automatically from a cartridge. At the beginning of the print, a build platform is lowered into the resin, leaving only a thin layer of liquid in between the platform and the bottom of the tank. Galvanometers direct the UV laser through a transparent window at the bottom of the resin tank, drawing a cross-section of the 3D model and selectively hardening the material. The print is built in consecutive layers, each less than 100 microns thick. When a layer is complete, the part is peeled from the bottom of the tank, letting fresh resin flow beneath, and the platform is lowered once again. Originally developed in the 80s, SLA was confined to large industrial machines until recently. Today, desktop stereolithography offers affordable, high-resolution 3D printing that fits conveniently in your workspace. SLA allows for the use of a wide range of materials with diverse physical properties. Whether you're an engineer, product designer, sculptor, jeweler, or dentist, there's a material for your application.
So this is how the platform, you can see once the material is scanned, it gets into a solid layer. So the platform goes again the downward. So again the fresh resin comes on the top layer. So this process is repeated again and again until the product is completed or printed. The main advantage in this technique is that the limitation of the wastage of material, and the next thing is about the precision. So here the precision of the component is very high and it is smooth also. So the process where you can have a smooth finished products. Whereas the cons, that is a disadvantage of the thing is it requires more time, and also it adds cost, investment cost. Thank you.